Hey everybody, this is Manish. I work for Intel from Austin, Texas, and today I'm going to share my experience with Intel's middle out journey to DevOps. What was our problem, how did we solve it, and how did the solution look like. So the agenda will be something like this. We will talk about the software process requirements and the challenges that we had back in the time when we started our journey. How did electric flow help? Because that was the solution of choice that we went ahead with. And unlike some of the other presentations, I'll spend a lot of time talking about the solution so that you can relate if the solution helps you in solving your problems. And then we'll try to spend some time on the Q&A. So one more time, I am a tech lead at Intel working from Austin. I have about 18 years of experience in software design, development and testing, working in networking and telecom all through this process. At Intel, I am with Intel for about 8 years now, and I strongly believe that quality products lead to happy customers, and happy customers keep companies in business. And the example that I always give is that even if you buy a toy from a dollar store and it costs you just $1, you still have some quality expectations out of it. So irrespective of the money that you pay, you have some expectations. So as a vendor, it's your responsibility to determine the quality that you are putting into your product and which your customer is getting. So what does my group do? We deliver SoCs to the top wireless telecom vendors in the world. So the Ericssons, the Huaweis, they are all of our customers, the Nokias. And whenever you make a call, whenever you browse through a YouTube video, whenever you are streaming something on your phone, the probability is that you are using some of the software and hardware that my team has delivered over some time. So at my home, I have this dilemma whether to prevent my daughter from having too much screen time or to promote her so that my company runs good in business. Okay, that's my bad, sorry. I was just too focused here. So what was my challenge? This was my challenge. We had too many combinations going on. Right here. So we had different OS platforms on which to validate our SoC. So the SoC is the silicon on chip. So the part that we are giving to our customer, it has to be validated on a bunch of software platforms, which are Linux, simulation, OSE, VxWorks, and you name it. And because it was a networking processor, it had a bunch of acceleration engines. So I need to do the deep packet inspection, I need to be worried about security, I need to worry about stream editing, I need to worry about timers, I need to worry about input output. And all of these features have their own plethora of tests that need to be validated. So what does it mean? It means that we have hundreds of test cases per engine, per block, and the total number of tests were just enormous. They are crossing 5 figures very easily. So before we started our process, this is how it looks like. We were making quarterly releases, as most of the companies were doing at that point in time. Our code was going with 85% unknown code coverage. That means we don't know what we were shipping out. And then we at that point in time, we were believing in God a bit too much, because if the customer does not complain, the God exists. And we were running a few hundreds of test cases per day, but because that's the maximum that the team can accomplish. And we had a whole bunch of permutation and combinations based on the slide that I showed previously for different engines, for different features, for different software platforms. So we'll come back to this slide at the end to see where we are today, but I just wanted to give a perspective. So at that point in time, this was how things looked like. That there was a current cycle time, which is some time that's taken by the development and some time that's taken by the testing. With every new release, with every new quarter, the development time is fixed because they are doing the incremental development, they are doing the incremental feature addition. But in QA, I need more time because I am validating everything that was validated before plus whatever new things were added. So theoretically, the testing should take more time. But what was the reality? The reality was that the QA is being hit twice. First of all, any overrun in the development, any slippage in the development schedule, and the first team that will be asked to compromise or to absorb that delay is the QA team. All right. So I'm already hard pressed because I have more testing to cover, more test cases to run, and on top of that, I have to absorb the slippage of my other team. So there was an unacceptable gap there, that this time nobody wants to budget. So how do we manage that gap? So we had a few options. We increase our cycle times and delay the time to market. Means you go to your management and say that, okay, thank you, give us a few months, we'll come back and meet you later. Or we shorten the cycle times and risk the quality. Again, we believe in God. We said, okay, we'll ship it, let's see. Or we had the third option, which is that we can test smarter and faster with automation. And I'm very proud and lucky to say that we decided the third route, and which is reaping us a lot of benefits today. So along with all these things, there were more reasons to automate. That the testing job is very monotonous, it's very repetitive. So over a period of time, if you ask the same engineer to do the same test over and over again, his productivity goes down because he is not interested in that job anymore. What happens? He will see the logs, but he will miss the common things, and guess who will catch that? The person who should not catch it, your customer. So it was very important that you keep your team interested and challenging, and the only way to do that is to automate. So how do we start? We had a few options. We can start investing in a homegrown solution, which will take more time, but you have the total control. Or you can go with the open source. There were not a whole lot, but there were a few options available at that point in time. Or we could go with a commercial solution. So let's see what we decided. We decided to go with Electric Cloud. And Electric Cloud, the specific product of Electric Cloud that we opted for was Electric Commander at that point in time, which is called Electric Flow today. And EC forms the single, flexible, scalable platform which gives us all the requirements that we were trying to meet, all the problems that we were trying to solve at that point in time. As we stand today, I have 99.9% automation for both the component level and the function level tests. And that 0.1% which I have not been able to automate is something in which there has to be a person physically in the lab exchanging the cables and switching the connections. So until I invest a few $1 million in the robots, I don't know how to automate that. So on top of the solution that we just bought off the shelf, there was a custom UI that we developed, because as the sheer number of combinations were huge, it is not possible to give that scale to the users and then expect them to use it, because they will be drowned in their own sea of the tests, and it's not manageable that way. So in the subsequent slides, I'll cover how we took the professional services help from EC and how we developed a UI. And after all of this is done, the results will be automatically emailed to all the stakeholders so that they are not stuck to a UI looking as to what failed and what passed, but they have the information ready-made in their mailbox. How did we achieve that? We achieved that by using the parameterization feature of Electric Cloud, where every project, every procedure, every step has a set of parameters that you can tune to your needs. These are the features or the parameters that were applicable to my use case. There will be something different for your use case, but I still wanted to share that for different branches, for different features, for different sub-features, whatever were my variables to select a particular test case, I parameterize that, and once these correct filters are put in place, then whoever is working on that, he can just filter out the test cases that are of interest to him. Okay, so this is a custom solution, but it is still standard enough because you're still looking at the test cases that you developed. You're still playing in your own workspace, in your own area, just that you're only viewing the tests which are of interest to you. And that helps in improving the maintainability a great lot, because whatever you can see is the things that you can manage. If I ask you to worry about 1,000 test cases, it will be pretty hard. But the moment I reduce your complexity to a handful, you are able to contain that, you are able to visualize that much more better. These test cases can be executed as is. As is means the way the QA team set them up, or they can be run against a different hardware. They can run by using a separate build, because different team, I do not want them to use my hardware. A different team, they may be having some code in development which they want to verify before they check in, or they checked in but they checked in into a private branch, and I don't want them to be stuck to my builds, so they can use their own builds. So all that was parameterized and exposed as parameter. So along with the QA team, as the product matured, as the solution matured, we started getting traction from the other teams also, especially the dev teams, which started using our test cases whenever there is a feature change. So for example, if there is a feature enhancement for one of my blocks, then that person will try to execute all the tests which the QA has developed for them for the previous releases, just to make sure that there is no feature breakage going forward. And that has drastically helped in reducing the end breakage, because once the code is committed and there are many people using it, it's that much more costly to fix that issue. Also, we have the complete feedback loops. All the stakeholders are informed by the emails. The regression results are sent to the management as well as the developer, as well as the QA person or the regression owner. So because all the stakeholders are copied, based on where you are in your life cycle, the appropriate person will take a look at it and be able to report any failure or do the corrective action as needed. The email notifier that we had, it has the complete information about which test was run, which build was used, all the hyperlinks to the logs and all that. I have a slide showing the complete template. So the intent was that the complete information about the execution should be available in a single screen, so that the person does not have to do back and forth, and be able to, any debugging should be fairly quick. So this is how the email notifier looks like. I'll just give you a few seconds to have a look at it. So all the fields of interest, like which build, which project, which branch, who triggered it, how much time did it take, and all the links to the logs. And the color is of utmost importance here, because green means good, yellow means warning, and red means that your test failed. So we have what we call as a Go Green initiative, which means that every team has the objective to make sure that all their regressions are green before we ship out a release. So this color is of very good significance here. So this is how the UI looks like, where all the fields are parameterized. I think it's small for you to, especially the people sitting in the back, to see, but it has the parameters like which branch we are working on, which features we are working on, which engine, which platform, and based on that, your test case list will be trimmed down dynamically, so that you can see that, okay, these 50 tests are what are applicable to this feature on this platform for this chip type. And then based on the nomenclature, you can decide, okay, which tests you want to run. And the fields which can be overridden, like do you want to run it against a specific build on a particular hardware, against a particular kernel, against a particular U-boot, all those things can be overridden, so that the execution is tailor-made to your environment. Over a period of time, we realized that the emails are not cutting it, far too many emails. So we thought of implementing a dashboard, which is like a bird's eye view on all the results. And this is specifically useful to the management, because instead of going to the details of each and every test, they can just go to this single page and see how much is green, how much is red, how much is orange, and take the release decision that much more quickly. Because that is the only thing they are looking for. They are not interested in what failed and when and how much, but just that, okay, is my overall quality good enough to ship out of the door or not? So we went ahead, and now these dashboards are used by the management, by the teams which we are feeding into internally, and definitely the QA team always takes a look at it. And the good thing about it is that you click on the red and it will show you all the jobs which resulted in this red failure. So you will see the jobs right there as to, okay, what failed, and then you can go to the history, whether it was passing last time, it just started failing today, or it has been a persistent failure. So all that information is available. How does it all work? If you are familiar with the Electric Cloud product, they all use the properties feature of the Electric Cloud. So every project, every procedure, they have these properties which we use to our advantage to develop the dashboard and to develop the custom UI. So another requirement that we had was that being a silicon test team, we had the reference boards, and for every test execution to happen, it is very useful, or it's required that we run the test on a specific board and only one person is using that board. So when the automation took the center stage and it is now a big time thing into your test execution, it was very important that this behaves like a human, goes to the reservation system, which is a separate tool that I have, goes there, marks that the system is reserved so that nobody else uses it, changes the configuration as per the test needs, and then execute my test. So this is just a small flow diagram of the flow as to how the reservation happens. And after the job is done, it will free up the board, which is now available for anybody else to use. And in the past 6 to 9 months, we are able to leverage more than just the automation part. We had the need, and I'm sure that a bunch of you will also have the same needs, that whenever you ship out the product, you are asked as to how much is your code coverage, how many tests you are running, are there any memory leaks, are you testing for the memory leaks in your software. And we had this unique requirement where our customer wanted that their previous applications should continue to run as is with the newer set of libraries that we are shipping. So we were able to leverage our automation for all of these three things, and the same procedures which were invested in a couple of years ago are now bearing fruits to generate these numbers, because all we needed to do was to run these tests against a specific instrumented software build, and all these numbers were generated and analyzed and available for analysis immediately. So if we do all of these things or any of these things in isolation, it is a product in itself. But courtesy the automation that we had, we were able to leverage all of that, and it was really a good bonus for us. So where are we today? We are making more than 100 releases a year, and if you remember, we were at 4 releases per year when we started. We have, oh, okay. So my QA lead time per cycle is now 10 minutes. It used to be days before. 85% unknown code coverage is now changed to 85% known code coverage. That's my goal. And my lines of code have not changed, luckily. And instead of running just hundreds of test cases per day, now I'm running about 12,000 test cases every day. So my test cases are categorized as daily and monthly and weekly. So based on the features and the release schedules, we select the appropriate tests that need to be executed. And all the combinations that I had to execute, I am able to support all of them. So just to summarize the benefits, we are able to manage that enormous amount of work that we had and is still increasing on a daily basis without increasing the headcount. So the key thing is that without increasing the headcount, which means that you didn't have to spend too much extra in investing in a resource and then training him and ramping him up. Instead, we bought this mechanical resource which can do the jobs that you want him to do. And we are able to make far frequent software deliveries to our customers. We are able to continuously monitor the health of the product. So even if we are shipping something out and we know that there are bugs, at least we know. Back in the time, we didn't know what we are shipping. So our trust in God is still there, but now we know what to expect as well. And I have more time at hand for my test development. So the same resources which were spending cycles over and over again, running the same test, rerunning the same test, now we're able to spend those time in adding more breadth and test and depth to my testing instead of re-executing the same thing. And again, at any point in time, I have a clear handle as to what's being shipped out. So here are the conclusions: that time to market pressure, which all of us are living through, it's a need of time that we need more frequent and faster releases. And quality is critical. All the customers need, even if they ask you to trim down your schedule by a year, they still want the best quality with 0 bugs. Now 0 bugs is their wish list. I don't know whether I'll be able to take them there, but whatever I can do. And Electric Flow and its capabilities has been of great help. So we thank them for that. And that's it. I'll be happy to take any questions. Sure.
Can you talk to what the single largest challenge was to get to that 12,000 cases a day?
Yes. Right. So the question is that what was the biggest challenge in automating those 12,000 test cases? So from a few hundreds to the thousandth, how do we reach there? So it took us 2 years. It was not an overnight thing that you flip a switch and it happened. And we started with the high risk areas, the first, where we were seeing more and more issues from the customer side. So that were the test cases, that were the features that we selected. And over a period of time, we extended that solution to the rest of the test cases. The biggest challenge was that as a SOC verification, I need to make sure that my environment is up to date, my traffic generator is hooked up, my reservation system is hooked up, my compilation is happening correctly. I am able to use the same scripts across the blocks, because if I have to write custom scripts for every test and every feature, it's too much of an effort. So bringing all of that on a single page, that took some time, but in the end, it all looks very beautiful, because whatever goes out of your door, there is a common look and feel. Whenever as a QA team we open defects for the development team now, they know the process, they know the grind, they know that what we are talking about, how will the logs look like, how is the compilation going to work. So it helped bringing that synonymity in the test code also, which is going from different testers but going to the same developer, say for example. Go ahead.
So on the slide that you have, benefits, there's a very interesting line item about monitoring health of the product.
Right.
So as we're going into the Internet of Things, where devices can actually give you feedback on the health of the device, are you prepared for that kind of feedback from the actual devices themselves to see how they actually are performing in the field versus what your test predict they should be doing?
So my use case was everything internal before the product is shipped out. So we did not have that use case to handle, but it was of extreme significance to me that if I pick a daily build, whatever the overnight build that got generated, when I put it into my test bed, how does it look like? Is it worse than yesterday? It's better than yesterday, or is it the same? So courtesy the dashboard, I have that visibility now, which I didn't have before.
In your slide where the test results were discussed, you have 3 kinds of results: red, yellow,
Yes.
green. If I can understand the red, I can read what is the yellow result in that.
Very good question. So glad that you asked that. So there are developers, there are testers. testers want to test everything. They have a test case designed, you open a bug and the developers say, good luck, this is not my priority, the customer is not using it as yet. But what happens is that this test is one of the 100 tests that I am running in the test suite. So every day the test is run, I see 99 green and 1 red, my overall email status is red. And every day the person has to spend 15 minutes clicking on that link and seeing, oh, it's the same old failure. So what we came up with was that we now have a way to categorize these repeat failures as warnings. So that is an indication to us saying that, oh, I know this is bad, but this guy has a history of being bad. There is already a there is already a ticket open. Don't worry about it. Don't spend your cycles clicking on this link. And whenever it gets fixed, you can go ahead and change me. So that is what the yellow color means here.
It's the equivalent of block.
It's the equivalent of that. It's a known state. It's a known failure.
Just go back to the after again, just to see the results here. Where you were.
Forward
Oh, forward.
to the backwards.
Right there, and then.
Four more clicks. 1, 2, 3. Perfect.
Okay. Go back. Okay.
Whoop.
What am I doing? Yes. Oh, you want to take a picture? Okay.
So you mentioned binary
Compatibility, yes.
So is that what we would typically associate with regression?
No. No. So, I'm afraid I'll not be able to give too much details, but look at it like this, that you have an application, you have a library, and if your customer says that you changed the library, but I don't want to recompile my application because I have a long process, and by the time my whole chain gets updated, it's a couple of weeks. But at any point in that big chain, I can just drop in your libraries and my test should continue to run. So how do I validate that? So what I take is that, okay, I use the old build, compile, I use the new build, run. It's the same test, right? So I'm able to mimic my customer scenario because I had everything automated. If a person is doing that manually, I have to double my QA team. Okay, I'm out of time. Thank you so much.